Now let's look at normalizing. Okay, we have z-score normalization and range normalization. So z-score is, every value is converted into its z-score. So z-score is, we already talked about z-score, value minus mean divided by the standard deviation. So you will have both positive and negative. Smaller values than mean will have a negative z-score. Larger values than mean will have positive z-score. We can use z-score normalization by simply computing. So you can do it like this. So we already have the numcols, okay, which is those three columns. Okay, z-score normalization is simply you take the numeric columns, subtract the mean, and divide by the standard deviation. So you get. So this is your NumPy universal function. So it's going to convert, and you can put them back into the data frame if you want as three different values. So you get the z-scores here. Okay. And then you can say, is the absolute value of z-score greater than 3? Remember, we were trying to figure out outliers. So you can do it this way too. Okay. And then we have range normalization. Range normalization is to bring all the values within a range of 0 and 1. So if you take each value and subtract the min value of the column, so the smallest value will have a 0 in the numerator because you're doing x minus min. So if x is the min, then you get 0 at the top. So that would be the smallest normalized value, 0. Right? And then you divide by the range. Range will be max minus min. So if in the numerator, if x is the maximum possible value, so your numerator will be max minus min, denominator also will be max minus min. So the ratio will be 1. So the smallest possible value is 0, the largest possible value is 1, and everything else will be in between. So that's what range normalization will do. So it transforms data between 0 and 1, and again you do the same sort of stuff. So you find, well, you could do all of this in one line, but I did it in 2 lines. You find the range, and then each value minus the min, right, divided by the range. So then these will be between 0 and 1. There will not be any negative values. Okay. Other possible normalization will be to convert everything between -1 and 1. Okay, that is another way of normalizing. Okay. There are a few others, but these are the two that are very common. Now, z-score normalization and range normalization. All right, so let's see. So we start with DFQ11 equal to DFQ6 dot copy. Okay. All right, generate z-score normalized values for the first numeric columns and save them into the data frame. Right. So we have n calls like that. Now we want only the first 2, right? So we can say, starting from the beginning up to index 2, so that will be 0 and 1, right? We can use this indexing to get only the first 2 columns. So this is what we are looking at. Okay, so we want for the first 2 numeric columns, you want the normalized values. Okay, so let's first get the normalized, set up the code for just normalizing. So that will be like DFQ11, right? and we want only for the first two. So we say n calls. Okay. So this is going to select just that first and the second numeric columns, because n calls is just the list of numeric columns. Okay. Then we subtract from that DFQ11, and again we have to go n calls, okay, and then we do dot mean. So this is our numerator, value minus its mean. All right. So let's put that in parentheses, so that will be the numerator. So divided by DFQ11, and once again we have to do only the first two numeric columns, and then we need to get the standard deviation. Okay, let's see whether that runs. Looks like that's good. So we have converted these two into z-scores. But we want to put that back into our data frame. So that's what the question is about. We want to put it back in. So what we have to do is to do DFQ11, right? Then we need two of them, because there are two columns that are converted into z-scores. So since we have two, we need to give that as a list. So we can say z. Well, we need to just make up names, z1 and say z2, and then let's print. Okay, so do I need a? No, that's it, right? Okay, so z1 and z2 are added at the end, right? Okay, generate range normalized. Okay, so the next one is range normalization, and once again that is also pretty straightforward. So I'm going to let's copy just that part. The question is not asking us to save it back. Oh, it does say save it back. Okay, so let's do the whole thing now. Let's copy the whole thing. Okay, now we'll call this R1 and R2, range normalized, right? All right. Now instead of mean, we have to have min there, right? The actual value minus min, and the denominator. Okay, now I have to put that in parentheses. So we need max here minus DFQ11 n cos 2 dot min, and then close parenthesis. So the denominator is the range. The numerator is the difference between the actual value and the min. list object does not have. So here, Q2. Okay, so that one should be another. I'm missing a square bracket there. And that's extra. Okay, so I had some brackets missing, so you get R1 and R2. Okay, and the last one is remove the original numeric columns. Well, we have done that before, so all you have to do is to just say drop dfq11 dot drop what drop n calls axis equal to 1, in place equal to true, then that will be gone. Right? So the two numeric columns that we used are now gone, and we have z-scores and then the range scores. Okay, thanks for staying 1 more minute.